Start momentarily. Okay, I think we can get started. Okay, welcome to MBONE. Here is the note well. You've probably seen it this week. This is a reminder about the processes and policies, including conduct, privacy, and intellectual property whenever you participate in the IETF. And please take a moment to review. And, okay. Session meeting tips. Please make sure, if you haven't already done so, to sign in to the, those of you in the room, please sign in to the Meet Echo. That acts as a way of keeping attendance so that we know how many participants we have, so that we get a right-sized room for our next meeting. This is also how we will manage the queue for the mic. So even if you walk up to the mic, you will not be granted a speaking role at the mic unless you are in the queue, and that is to ensure fairness of the remote participants. Do the on-site version, of course, and remote participants, please stay muted unless you have something to say. And a reminder, if you do come to the mic, please state your name and affiliation. All right, here's our agenda. We have a reasonably full agenda, a good eye chart. Any bashes to this agenda? Okay. And let's go with the status of active working group documents. First is the Yang models, multicast Yang models. The Yang doctor completed that. The draft was updated as a result of the Yang doctor comments, and it is in working group last call right now. So we encourage folks, please do comment whether you support or not the advancement of this document. We want to have rough consensus to advance. We previously had a working group last call and didn't really get much feedback from anybody other than the authors. So we need to hear more from more than just the authors. So I think I've seen a few messages on the list in the last day or so. Please review the doc and comment on whether or not you support its advancement. Same thing with the Yang, the AMT Yang. That is also that had since 123. We had Yang Doctor's review. It was updated as a result, and it is also in working group last call. So same deal with that one. In multicast, the redundant ingress failover. That had Ops Directorate and Routing Area Directorate gave comments that indicated that probably it needed, it was a ways away and needed some significant enhancements. Authors, Greg, do you want to talk about where that one is?
Nothing about this authors.
Where'd that come from? Which one? Ingress. Redundant ingress failover.
Oh, gotcha. I thought I heard Yang. I need to put my ears on. But yeah, we actually had a con call 2-3 weeks ago, and Sandy did a great job of getting the language all correct, some of the issues that were there. But I think there was a gap in understanding what the objective of the document was. I just focused on, okay, let's get the abstract correct so people understand there's operators looking for a framework. It's not configuration. It's not inventing anything. And it was kind of in the spirit of there's a MVPN draft, I believe. I don't know what the RFC number is off the top of my head, but it was mentioned later in the document, and I thought, okay, there it is. Here's something that articulates a solution in a given space. Let's cover the rest of the space, and modeling that as extending what was there. So I kind of put that in. So now I think the document reads better in that we know why what we're doing is what we're doing, what problem we're trying to solve, and then goes on and explains. So I think it should be ready after this, at least for the group to look at it again.
Okay. Do you think when's your next? You think it'll be ready for next?
Yeah, I think so. I mean, Sandy edited the last rev of it, and it's like ready to get shipped. So as soon as it's open, we'll be shipping it.
Then there's the dorms doc and the CBAC doc. Max is going to give updates on those. And Ambi, that's still a ways away. Seems like that has a fair amount of work. Max, if you want to, when you do speak, mention where Ambi sits and any targets for completion on that one. There's the non-source routed SR multicast draft that Jeffrey's going to talk about today. And Kyle, do you have anything to say about the your security draft? It was adopted last month.
Yeah, not much to say other than I would, it hasn't moved a lot in several years since I first wrote the draft. Since adoption, it was just had pro forma changes to move it into adopted status. So if I could get folks to review that, that would be really helpful. I don't know how much work is actually left to do on it, or if it's really a matter of getting consensus that it looks good and complete, and then to get some reviews from sector and other places on it.
Great, thanks. And with that, let's go to next up on the agenda, which is me. Okay, just a plug that we will have a side meeting tomorrow at 11 a.m. in McGill down the hall. What is the purpose of this?
You have to turn it on.
Have to turn.
it on for you right now. I saw you walked it without it.
I got this.
Go. Yeah, now it works.
Oh.
Right. I'll show you.
Okay. All right. Cool. That's good to know. All right. What is the goal of this? The purpose of this side meeting? Recent events, and specifically in the last 3 years, the world is different than it was previously when the internet world is, when it comes to live streaming. 10 years ago, live streaming was less than 1%. Now it's up to 17%. The things like, and what happened to change this, really Thursday Night Football started 3 years ago. And Comcast has come out and said that Thursday Night Football, that game represents 25% of all internet traffic that they see on that evening. And it's not just in the U.S. This is something we've seen all over the place. No more so than probably in Asia, where the numbers for cricket, IPL, and the World Cup are just kind of astounding. From 30 to 40 to 50 and now 60 million simultaneous viewers earlier this year. And then really the big seminal moment was the Tyson fight, the Tyson Paul fight that set several internet records, 65 million viewers, plus 85,000 complaints and 3 lawsuits. The point is, these massive events are not just one-offs that we can just dismiss. And even because they're happening pretty routinely, and even if they were one-offs that we could dismiss, the problem is that capacity planners need to plan for these peaks, not just for average. It is stressing the limits of what CDNs and service providers can do. A key thing to keep in mind, live streaming is not the same as on-demand video. It's actually far more demanding when it comes to things like latency and join rates. And the point of this is there are multicast solutions that are existing and emerging and occurring kind of in two different worlds. There's the network world, us in this room, and we have things like SSM and AMT, and you squish them together and you have a TreeDN. And in other working groups, there's lots of innovations going on at layer 4 in the working groups as well as outside. So things like DVB, MABR, MAUD, open casting at SVTA. There's some work being done on multicast extensions to Quick that some folks here have been involved in. That's going on in the Quick working group. And things like ultra low latency using UDP. We're going to have a talk later today about that. The key thing is these things are happening in these two different worlds, and there's not a lot of these two worlds mixing. And so I think there's maybe some myths and misperceptions about what is going on in each other's worlds. So the goal is to bring people together in the same room from these different worlds to discuss what are the challenges when it comes to using multicast for live streaming. We want to do a gap analysis. What's working today? What's missing? And the primary focus is on that layer 4 and above. So the areas we really want to look at are things like reliability, ABR, adaptive bitrate, encryption, different DRM and access control, congestion control, all of these items that ad insertion. These are things, there are innovations going on elsewhere, and we want to look and see, are they applicable to multicast, and are these solutions there, and what's working and what's not. In terms of the agenda, we'll have 3 different presentations, and then an open discussion for about at least a half an hour or so. So really encourage folks in this room, please come, please join, and bring a friend, particularly if those friends are in the streaming world. With that, any questions? Cool. Look forward to seeing everyone. Okay, next up is, who is next? Max? Max, you are up.
Yep.
I'm going to bring up your slides.
I guess.
Here, stop. How do I stop? There we go. Go back to there. Okay. Oh,
I
yeah.
think you can give me control somehow, right?
There you go.
Perfect. Yep.
Max, I don't know
All
if you
right.
heard, but if you could also at some point also just mention where Ambi lives. And
Yeah,
what's
yeah.
going on with that.
Thanks. Okay, I would also probably not need 25 minutes overall, but let's see. So yeah, this is an update for the DOMS cluster, right? Started by Jake, and now Kyle and me took over basically last IETF. So quick update. There has been quite a lot of things happening with DOMS, some things recently with CBAC as well, and then Ambi, just to get out of the way, there was the new revision, but there was basically no changes, and it's pretty much on hold again until we progress with the security draft a bit and see which actual things Ambi is supposed to fix and what it's actually supposed to do. So the main focus of this talk will be on CBAC because that's the thing where most things are happening right now. Sorry. So just really quickly to recap in case you weren't there last time or forgot since last time. This cluster is made up of 3 drafts. The cornerstone is DOMS, which is a way where you can retrieve metadata for multicast stream based on the reverse DNS zone of that SG. So you use the SG to basically, and then DNS to get some metadata, right? And DOMS just specifies this mechanism itself and doesn't specify anything, any specific metadata yet. Yeah, and the point is that it's extensible. The first extension to this metadata retrieval service is CBAC, and this is the second draft, which is supposed to act like a circuit breaker as defined in RFC 8084, which basically is a way to handle unresponsive traffic, so traffic that isn't congestion controlled, like UDP, in this case multicast specifically, and CBAC basically tries to implement the mechanism that allows middleboxes to basically decide which channels to prune and so on if there's congestion. Okay, so MB would be the third, but again, since nothing happened there, I'm not gonna reintroduce it, but it's basically a way to add integrity also as an extension to DOMS. Okay, so what happened with DOMS itself since last IETF? We received 3 early reviews, so one from Ops, one from Jennard, and one from Young Doctor. So thanks to those guys, and also to Matt, who did a PR with some fixes as well for the Yang. They all said it was basically ready and only had minor issues, which we all addressed in the current revision. We're still waiting for the SecDIA review, which is now overdue by like 2 months or something. But yeah, I think, or we think the draft is ready for working group last call now. So yeah, that's pretty much the status of DOMS. Lenny, maybe really quickly, what do you think to do now with that?
I'm sorry, one question. Kyle,
Sorry.
I remember you said that there was an item that came up and you said, I will add that to the next rev and send it. Did that happen on dorms?
Yeah. I think it did.
It was brought up on the list. Something was brought up on the list, and I believe you said.
I'm pretty sure we
add
resolved all
that.
the outstanding
Yes.
comments. If that's not correct, somebody let me know. But I think
Okay.
I think we resolved everything outstanding. There was a Yang Doctor's review that pointed out some things, and then there was also an AD review. Was it Mohammed who
Yes.
Yeah.
gave us feedback? Okay.
Yes. I think so. All right, cool. So it's ready as is to fire off the
Yes.
working last call.
Yeah, modulo, I don't know, like Maxaby and I have been talking about some.
We'll come to that.
let's talk about it maybe when we talk about CBAC more. I don't know.
Yeah. But yes, DOMS as it stands, probably ready. Yeah. Okay. So on to CBAC, which again is the more interesting part. There was a review from Brian that was already there last IETF, but we updated it. So we went through it again, and we noticed there's quite a lot of things that could be improved or changed or make more sense. So the way it works currently in the current state is that basically you take the metadata you get. So you're a middle box. You retrieve the metadata you get from DOMS to get the estimated bandwidths or the maximum bandwidth rather, that each multicast channel has. And based on this metadata, you decide, and you do this not proactive, but reactive, right? You do it constantly. You check how much bandwidth is available, which channels do I have, am I over the capacity based on the metadata I get? And if I'm over the capacity, there's a mechanism that is used to basically decide which streams to cut or which channels to cut. And in our opinion now, this seems, first of all, not to be a circuit breaker in the sense that there's no active measurement, right? Like the other circuit breakers based on 8084 have basically an ingress and an egress meter, and you measure how much data you get in the egress, how much do you get at the egress, and based on that, you can detect that there's congestion between the two, and then you trip the circuit, right? But the ingress meter in CBAC basically is the metadata you retrieve. So the first... Okay, so based on this understanding that we now have, from reworking the draft or getting deeper into the draft again. We presented this at CCWG yesterday, which there wasn't a lot of comments at the group itself, but Kyle will write a draft for the mailing list, and Gori and Reese were enthusiastic about continuing the discussion on the mailing list there. So this congestion control mechanism definitely has a space there for them. The point is that we want to change it now from the way it is, where you only get the metadata, to use the metadata to actively be proactive, because in our mind that makes a lot of sense, right? So before you actually join the channel, before you propagate the PIM join or whatever, you check, will I actually have enough capacity for this channel? And if I don't have enough capacity, then I either call a different channel to make capacity if I decide the channel I want to join is more important, or I just don't join the channel. That's part one, right? And part two is that you actually do active measurements, right? So you actually have an ingress meter and see how much traffic, multicast traffic, do I actually get on this node? How much egress traffic do I have? And how much actual congestion on my multicast data is there? And then just act like any other regular circuit breaker. So this is the congestion control circuit breaker bit part of CBAC, which maybe doesn't fit that's the thing, right? This needs to be discussed at both CCWG and MBOND. This document lives in MBOND, and Gori said yesterday that he agrees it should continue to stay here, right? So it's not like CCWG will take this over. The thing that's more interesting, more relevant for MBOND now is the part about the trigger functions. And currently in the draft, basically there's also metadata for priority for multicast channels. So if the same source has multiple multicast groups, basically the source can tell which multicast group has higher priority than other ones. So the flows, as you can see, it says their flows from a single sender must be ordered according to their priority field from the CBAC metadata, which when compared with each other. This takes precedence over fairness functions and so on. The point being that you can have multicast applications where one stream or one flow depends on a different flow, right? Or where one flow doesn't make sense without the different flow. Sorry, Kyle. Go ahead.
Yeah, no, I just wanted to illustrate maybe with an example of the difficulty, and this gets into what I was saying about dorms before. So in a production environment that's making use of some of this stuff, right? Networks are going to have relationships with content providers, and they're going to want to prioritize some content over others. Like maybe if Comcast has a relationship with Netflix or something like that, and like agrees to prioritize their traffic, if they run into congestion, they're going to want to cull other things first, right? So really, the priority on a stream is a function not of what the provider says, because of course all providers think their stuff is the most important, right? It's really a function of what comes down to business relationships and deciding what traffic should be prioritized in the event that you run into irreconcilable congestion. So we're not sure if the priority field in the metadata as is makes sense. And the thing that I was getting to about dorms before is it may be that we actually want the metadata that is provided to middle boxes within a network to essentially be sourced or modified or filtered in some way by the network itself, right? So the network, like if you have a middle box that is connecting to a dorms metadata endpoint, it might want to be a dorms metadata endpoint that is essentially replicating what upstream says about the stream, but adding its own additional information about prioritization so that the middle boxes can make more informed decisions based on the underlying business relationships about which traffic takes priority. It's a little complicated, and I haven't fully thought out the implications of this, but that's why I'm saying it might require some changes to dorms. I'm not sure yet. Does that
Yep.
make sense to people? It's a little complicated. All right, that's it, Max.
Yep. Okay, so yeah, as Kai already said, the idea is that, and this is where I would like some feedback from the working group, is what to do with this priority field, right? Option 1 is just keep it as it is. Option 2 is that you change it because the priority itself might not make that much sense. Instead of saying, okay, these streams all belong together. If you need to remove one, remove all of them. Or if we just punt the topic and say, remove it for now. And because DORMS is extendable, we can have time to think about what Kai mentioned, how to properly do this priority and based on different metrics, and then have a different DORMS extension that can be used to prioritize or deprioritize multicast channels independent of CBAC. And CBAC would just be the actual mechanism to call them. Yep, Kai?
Right. I mean, one of the things that we were thinking was that having logic in the middle boxes to like look at metadata and understand cross-stream dependencies and all this would just be like way too much. I mean, a lot of these middle boxes are just going to be routers, right? And they need to be able to do something very simple. And so I think it's probably the right approach to rely on, let's say you had some expensive stream where you culled the video part because it was, I don't know, 20 megabits or something, and you needed that back. You should rely then on the client to also then subsequently cull the audio stream because it's not getting video anymore. So chances are it doesn't want the audio, or it's going to switch to a lower bitrate video stream or something like that. And so I think the current thinking that we have is to push that kind of logic to the client. So when you cull an expensive stream, you then rely on the clients to do something sane in response to that about whatever other dependent streams there are. Makes sense, in Max?
Yes. So that's why I think we feel that option 3 is the most sensible for now. Just remove it, and then if there's any use case where you actually need the sender to tell you priorities and so on, you can just do another DORMS extension and reintroduce it there. But we feel like it might be making CBAC more complicated than it has to be and giving middle boxes more to do than they should have to do right now.
Right. Are you going to cover the CBAC is has traditionally just been like circuit breaker, right? But then there's also the issue of of unmovable load and like how that relates to other TCP traffic. I don't know if you were planning on getting into that.
A bit in this slide, I think, right? So this is now, okay, so first of all, maybe any questions, comments on the priority? Do people think it even makes sense to have at all that you say, okay, this one channel relies on other channels and so forth? Jake's example was Flute, for example, right? Where you have two different multicast groups and one relies on the other or is useless without the other and so on. So is there any strong opinion on saying, okay, we definitely need this priority field? I guess probably not. Okay, then so
Might be good to bring it to the list as well, just for folks who aren't here.
Yeah.
But it doesn't look like there's strong opinions in this room.
Okay. So, and now finally, based on all these new understandings, we have the overall plan we now have for DORMS and CBAC would look like something like this, right? So you have the middle boxes that act as both circuit breakers and also act preemptively to never actually join channels that would lead to congestion. This part is basically, or can be solved in CBAC without that much changes, right? So this can be done easily, but can be done with what we have now. Then the second part would be that the middle boxes, or in ideal case, or in our vision, middle boxes also signal to some network controller that they now needed to remove a certain stream because it was too expensive, which would obviously need some signal mechanism, but we haven't really looked into that yet that much, if how easily that is to do, but probably there's things there. Then step 3 would be that the clients, so the receivers, actually get the metadata from the network controller, or they can pull it somehow, right? So also with local DNS servers, for example, or resolvers, rather, provider-hosted DNS resolvers, you would get the metadata specific to your local network, right? And then based on this information, they could make decisions on, or they would understand that, okay, I will not get this multicast channel because my network doesn't support it. So I don't even have to try to join it or wait to receive data. And I won't be surprised if suddenly there's no data or anything, because I know, okay, the network just cut it off. And the clients, based on these metadata, they would be able to then make more intelligent decisions in which multicast groups to join, which multicast channels to join, and so on. And right now, it feels like a lot of it is guessing work, right? Like if you look at IGMP or PIM, there's, as far as I know, not really a mechanism that tells the client that why a channel wasn't joined or something like that, right? There's like no mechanism. The clients report, I want to join this channel, but you never get any feedback really, right? So we think without reinventing the wheel or anything, if there's something like that we're just not aware of, but we think that CBAC and DOMS can also be extended to accomplish this task. And we think that would be a useful thing to have in place as well while we're at it. So for the last, or for part 3, as I mentioned, it's quite clear how to do it. If a local resolver is used, right, then you just get the DNS, the appropriate DNS record pointing to the appropriate DOM server. But if it's not clear yet what you would do if 8888 is used, for example, or something, right? There we have to think about the mechanism and how to do it properly. But this in general would be the plan to work towards this, right? To have more meaningful and more information provided in the end to the clients, right? Without interfere, or like without cutting back what DORMs and CBAC and so on were initially used or intended to do. Okay, and that's it from my side. Kyle?
Yeah, I think one of the things that we realized was that circuit breakers are a very blunt instrument, right? Unlike, TCP congestion control is very fine grained. If you have a bunch of TCP streams competing for some constrained link, they will more or less approach some fair equilibrium between them, right, by adjusting rates to deal with loss or latency. Circuit breakers are all or nothing, right? If you decide the stream is too expensive, you just cut it off and it stops completely. And so it's not really it runs into this problem where bandwidth seeking applications like TCP push out quality seeking applications by just consuming more and more bandwidth, and then the quality seeking applications start reducing the bit rate of the stream they're subscribed to because, hey, the link is congested and I'm seeing loss. And so like it's unclear to me how operators would deal with that problem in reality, other than just putting in big enough pipes to handle all the traffic that they see, which is probably what they do when it's general internet traffic. It's easier when it's got its own bearer. So like for instance, if on a typical cable network, right, you've got internet traffic is on one set of frequencies and TV traffic is on another, and they might both be using IP, but they're not competing for bandwidth. So when you have these applications competing for bandwidth, you probably need to, instead of looking at link utilization, which if you're doing like a software download is going to look like 100% all the time, so it doesn't give you any information, you want to look at what percentage of the link is media traffic, and maybe put a ceiling on that and say if the unresponsive load, the media traffic exceeds that, then we'll start performing circuit breaker operations, as opposed to just looking at link utilization. So anyway, there are some things to work out here, and this is something that is probably going to require some real world experiments to get right. So
what about there? I know you guys are planning on sending this to CCWG. Do you think good feedback could, enlightening feedback and insightful feedback could come from that.
Yeah, that's what I'm hoping. Like that's what
Yeah.
next week I'm going to write essentially an intro email describing the set of issues that I think we're running into and get feedback from them on what they think the right way to handle that is, the right way to move forward. Because I mean, I don't think any of my observations here are novel, right? It's not a circuit breakers as a concept are still pretty new, right? So I think that we may wind up being the guinea pig really testing these things in the wild for the first time and getting experience with it. So
Of course, multicast congestion control is always the big, or like one of the big issues, right? Like if, especially, I mean, CCWG, I remember when they chartered, there was a lot of discussion if they should include multicast at all or not. And in the end, they did include multicast congestion control. But I think having this could be one way to realize better multicast congestion control in the end, right? Ultimately, if you somehow if the middle boxes are somehow able to tell client and sender, receiver and sender, that they need to cut streams because they can't handle the traffic, then maybe both the receiver can obviously respond by joining a lower bitrate or whatever, but maybe also the sender eventually could respond and say, okay, I will need to create a channel with even lower bitrate or whatever, right? Like this is just more data that can be used to make decisions to realize congestion control like behavior, maybe ultimately, which of course with multicast is incredibly hard. Yeah. Okay, that would be it from my side.
One other question. At one point, this was seen as all three of these drafts would go as a cluster when we advanced them. I guess we're not doing that anymore. They don't need to be clustered.
No, I don't think so. I think Ambi is too far behind, and I think it's good if we have DOMs in place because then we can think about the extensions, right? If we need other metadata instead of just what CBAC is providing right now, which is the maximum bandwidth, right? So from my point of view, they don't need to be clustered anymore.
Gotcha. Any questions from anybody in the room? Great.
Right.
Thanks, Max.
Thanks.
Okay, Jeffrey, you are up. You have 10 minutes. 10 minutes. That's a hard 10 though. Okay. And I'll do this.
Okay. So I'm representing this on behalf of co-authors, Ice, Woman, and Yisung, myself. And a quick background. This is an informational draft focused on the non-source routed options for multicasting SR networks for discussions and considerations. It was adopted as a working group document in April. The authors believe it is ready for the next stop, which is last call, we hope. It has been quiet on the mailing list, so we are basically represent this to hopefully trigger some discussions before we request the last call. To talk about the SR multicast options, we want to have a quick review SR principles. So the number one principle for segment routing is that we don't have per flow or per tunnel states in the network. In the case of a multicast, that means that we don't have maintain per tree state. The second principle, or really it's a characteristic, is that optional use of controllers, where the controllers does the tree calculation or even does the signaling. So if we consider the principle number one of segment routing, which is no per flow state in the network, then we have two options. The first one is ingress replication. It's simple, mature, but obviously the replication is not efficient. However, it is applicable for certain scenarios. For example, you have low rates, you have low fan outs, your flows are sporadic, where the setting up the tree is just not worth it. And when you do the ingress replication, you can use both segment routing or non-segment routing paths, whether it's IP, MPOS, or SRv6, whatever. The next one is beer. It does allow efficient replication without causing per tree states. And that is perfect solution for SR multicast. Interestingly, both ingress replication and beer were developed independently of the segment routing. So a quick update on the beer status. We had good protocol progress in IETF. However, deployment has been lagging behind, mostly due to the chicken and egg dilemma. The operators liked it initially, and then they asked vendors, when can I deploy it? It turns out that it requires a new hardware. So they back off. And when the operators back off, the vendors also back off. So they'll get into this situation. However, we still believe that as a good technology, its prime time is coming. We have pioneering vendors and operators. They will help break the dilemma. We have basic capability from several major vendors across the edge, access, and core platforms. We also did some interop testing among major vendors. So now consider the second principle, which is the use of controllers. There are two options here. One is that you use controllers to do the tree calculation, but then you still use the traditional protocol to set up the tree. Another one is that you use controller to do both the calculation and signaling of the trees. In this scenario, we have actually two options here. One is the SRP2MP. It uses the SR replication segment that was defined in the Spring Working Group. It's already RFC, and that's just basic building blocks for the SRP2MP. And in the PIM Working Group, we have this SRP2MP policy, which talks about how to set up the SRP2MP tree, and it's already in the RFC editor's queue. And another option is to use BGP to signal MLDP and IP multicast. That draft is defined in the best working group, and it's actually ready for a working group last call. We're just pending the final IDR review. A quick clarification here about BGP signaled MLDP. It sounds strange, but here we're basically using MLDP FAC to identify the tree in the control plane, but we do not use LDP protocol for signaling. This is a good option to transition from the traditional MLDP-based MVPN to new controller signaled multicast trees. So there are some considerations for SRP2MP. If you have MPOS data plane, then in the data plane, the SRP2MP is actually similar, or I should say identical to MLDP or RSVP P2MP, because the tree nodes have per tunnel forwarding state identical to the case of MLDP or RCP P2MP. You have an incoming label, you do label lookup, you find out how to replicate the traffic outs using labeled forwarding. The only difference is in the control plane. Now we have different tree identifiers, and you have different ways of signaling that tree. And then SRP2MP avoids tree state on the non-replication nodes, which is good for sparse replication situations. PIM MLDP actually supports that as well. It does require PIM adjacency over tunnels or MLDP signaling over targeted sessions. In the case of SRP2MP, this is avoided by use of controllers. I'm going to skip the SRV6P2MP for now. I see that my time is coming up, but so we talk about those options according to the SR principles. Now there is another set of solutions, basically with the traditional solutions, traditional ingress replication, PIM tunnel or MLDP or RCP P2MP tunnel. Those solutions can still be used as long as they address the use cases, your use case without any pinpoints. And in the case of SRv6, where you do not want to use MPLS anymore, you can use plain old IPv6 multicast. So then the wise, there are operators, they say that, okay, I am doing SR for my unicast. I got rid of LDP, I got rid of RCP. Why should I bother with MLDP or RCP P2MP for multicast purposes? Yes, that is really a choice of the taste, is your preference. Some operators say that I don't, sure, I'm not using it for unicast, but I can still use MLDP or RCP P2P for multicast. Some operators say that I just want to get rid of those old protocols now that I don't need it for unicast. And they also, that may also the situation be the situation where they say that I want to use controllers, so therefore I don't want to use the traditional solutions anymore. So all those options are valid. So we have a list of the considerations that you can one can evaluate. So first one is that if you care about efficient replication, you don't want to have per tree states, and most of your replication nodes supports beer, then obviously beer is the #1 choice. But that may not be the situation. You may have a network where you cannot deploy beer for quite a while. In that case, what do you do? To me, the traditional multicast solutions it could be considered as long as they address the needs, and you don't mind running those traditional solutions. But if you are you do want to get rid of those old protocols, sure, you can use the newer solutions, SRP2MP or BGP signal, the MLDP or IP multicast. Just keep in mind that they will still have the per tree state. So, as I mentioned, this has been adopted and it has been quiet on the mailing list. The authors believe it's ready for last call. But if you do not agree, please bring it up on the mailing list, or even now, if you have time, we want to talk about this. We want to see if this makes sense to most of us, and then we can so that we can move it to next step, making the information RFC.
Great. Yeah, definitely. Just a plug. Please do review this. This is a topical issue. We're running into more and more networks that are moving to SRv6, and they're saying, how do we do multicast? So having good, clear, well-reviewed solutions and guidance from this working group would be helpful.
Niels, Deutsche Telekom. I just want to say I reviewed the draft and I would also agree that it's ready for last call. So support +1.
Great. Thank you, Niels. Great. Thanks. Okay, next up, Craig. In a moment.
So
now it should work. No, now it should work. Yeah.
okay. Hi everyone. My name's Craig Horobin. I'm the founder of Aircast. Aircast is a sub-second latency in-venue streaming using multicast distribution. We really appreciate the opportunity to probably just give you an overview of an implementation that we've done and ultimately what the product and the service that we're delivering for major sports events. Certainly to start off with the in-venue, but also to speak to you guys and get some maybe get some ideas about, you know, expanding that into the WAN. So obviously I can see that this working group is certainly focused on that and also working with multicast. I've also got Dr. Sanjay Gupta, who our CTO as well. So any other technical questions and everything at the end of this, I'm sure that he's probably best placed to answer. Okay, the challenge. So real-time streaming in high density environments, always been a problem. Not very easy to achieve. High user density and constrained spectrum. And this is when we're talking into a, ultimately in a stadium environment, you know, obviously packed with fans. Thousands of concurrent users demanding low latency. Traditional unicast streaming causes congestion. And the ultimate need that we're finding, certainly with our clients, is for sub-second latency and consistent quality experience. All about getting real-time information, video, audio, data. Introducing what we've developed, Aircast, which is in-venue low latency streaming platform. It's designed for broadcast grade reliability. And what we've built is an Aircast SDK for integration across devices. It's built for scalability and for interactability as well, but utilizing again multicast, which I'll get to shortly. The user case that we've just completed is the US Open, where we deployed Aircast, which provided sub-second latency, ultimately delivering real-time content, experiencing instantaneous streaming, sub-second latency, stability with performance within venues that were quite dense, live streaming from multiple courts simultaneously as well. So enabling fans to switch between feeds and games, depending what so being able to access that content in real time, whether that's video or commentary. And crystal clear real-time audio, so switching between commentators so that they understand exactly what's going on at any given time. This is an overview, very high level, of our integration, our implementation, and how we essentially use this multicast distribution architecture. So starting off from the left, production, getting all of those broadcast streams, those production feeds in SDI unencrypted, commentary as well, so all those radio feeds, but also the commentary feeds that are already embedded within the video. Ultimately, there's additional content that may be available that we would ingest into our server, which is essentially on site. So we take all the feeds in within our box, we take them in unencrypted SDI and send that through the local network over IP. So essentially from our box, we would connect directly into the local network, and that would connect to the entirety of the actual precinct or the venue within the stadiums, but also within the Flushing Meadows precinct, which we just delivered. Fans and professionals alike would actually have access to that SDK, download the app, and have instant access to each of those feeds coming directly from production, but also, as mentioned before, the commentary as well. So giving fans that fully interactive, immersive experience to understand the full context of the actual game that's going on wherever they are in the venue. Okay, so also what we've been able to do utilizing multicast distribution is multiple feeds. that gives you access to each of those feeds in one, if you so desire. Instant stream switching with multicast authentication. So once you open it, our server authenticates that feed that allows you to have that direct access. Seamless audio-visual synchronization, enhanced user controls and experience. So adapted multicast innovations. This is just a comment from the guys at USTA, so the US Tennis Association. Ultimately looking at this as a real problem solver with regards to having access to real-time content that is enable fans to understand and have a really immersive experience across the board. It also, at this point in time, you have the picture here shows one of those Amex analog radios that people actually go in, they purchase, they use, and what Aircast would do is actually remove the need for that sort of service. Everything is available through your phone, and ultimately, you know, that's a seamless user experience using the technology directly to their end user device. Lessons learned. So underlying IP transport, key dependency, so importance of IGMP tuning and coordination. So just making sure that those issues are resolved. Consistent AP firmware upgrades critical, and that's essentially what we found. Buffer management essential. So what we've developed within our SDK is to minimize that buffer within the player so we can achieve that ultra low latency. And venue topology effects coverage optimization, which is obviously a given just to understand exactly what network's in place and what changes need to be made once that's in. What we read, and I'm sure all of you as well, and having deployed Aircast in several venues, multicast makes IT departments nervous. Everybody probably knows that and has probably come across the same issue. What Lenny mentioned before and what we've started to recognize, which is really good, but there's an openness that's started to begin to be open to this idea of multicast and real-time content. So I do believe that the attitude is starting to slowly change, and ultimately forums like this certainly help to understand and obviously, you know, change that attitude. Future direction, yeah, looking at time shift is requested by customers, being able to scrub back in real time, integration with 5G, MBMS services, increase interactivity, and that's what ultimately where the technology is going, and wide area network distribution. So as mentioned at the start of the talk, this is what we're really looking at. We've built a solution that's been really looked at within the in-venue environment, and ultra low latency, as you would know, is becoming more important for a wide area distribution. So love to chat to some of you guys after this forum. Any thoughts on that? Summary. So sorry, probably gone a bit quicker. I probably didn't need the 20 minutes.
It's not over yet. There's plenty more questions.
Okay, good. Aircast delivers low latency at scale, multicast and mobility, provides a superior experience. Many companies have essentially tried to achieve what we've done before, and obviously unicast just does not do that in congestion. Proven success at US Open, Golden One Center for the NBA, and yeah, foundation for scalable live streaming architectures. And yeah, thank you, and love to get any questions. As I said, our technical expert here, Sanjay, is here to answer anything further if it's more technical, but yeah, thank you for your time. Yes,
Kyle.
Kyle Rose, Akamai. What did you learn about rate control? The reason why I ask is that it seems like for something like this, right? Since multicast on Wi-Fi essentially comes down to the lowest rate that you support, did you have to set like a minimum, like you have to have a phone at least this recent to connect to this?
Yeah, look, we did. There's certainly, we had back to, I think, 12s or 11s with iPhones. Ultimately, we basically built our SDK to make sure that we didn't have any issues with regards to receiving those signals within the venue. Does that answer your question?
Yeah, I'm just sort of wondering what kind of headroom you needed, right? Like, so if if you need, I don't even know what they are, right? If you needed a minimum of, 300 megabits or something like that to be able to support all the simultaneous streams at the same time.
Yeah, so we had around 3 megabits for each stream, so 3 to 5 megabits for each stream. So we were taking the main venues plus the audio as well, which is a few kilobits for each of those. And ultimately, what we delivered was directly over the normal guest Wi-Fi network. So there was 22 SSIDs within that network. So what we did is we actually achieved really good, stable quality streaming. So yeah, 5 megabits per stream or thereabouts for each of them.
I was just curious.
Sanjay, if you could grab a mic so that our remote listeners can hear you.
Yeah, I'm
Yes.
Sanjay. Sorry about that. So yeah, we did set a minimum multicast rate, right, which was 48 or something, if I remember right. So this way, we knew there was going to be sufficient bandwidth for us to transport all the multicast video channels. Now, if some client was far away and it couldn't support that rate, tough luck. Yeah. But this is why getting a good Wi-Fi infrastructure is extremely important, right? You can't fix that problem.
Right. Yeah. I mean,
So
like home Wi-Fi equipment even home Wi-Fi equipment has like minimum rates on things because you don't want somebody bringing their 802.11
absolutely,
feed device and plugging into your network and suddenly everything slows down, right?
Exactly, and we did that exactly for that reason. Okay. But I was going to say, credit to the US Open team, and we worked with them, and they had amazing Wi-Fi coverage. That is actually improving next year, by the way.
You mentioned IGMP tuning. Can you elaborate? What was the problem? What did you have to do, and what worked?
Sorry, Sanjay, I'm going to ask you to answer that one if I could.
I think maybe this is a topic we should discuss offline. We can get into the weeds on this one, but there were lots of little tweaks that we had to do to make sure that the underlying IP network was solid and multicast traffic was being managed correctly and so on without creating all kinds of flooding in the network, which we did notice, by the way, did happen through some rogue clients out there.
These host tweaks to the IGMP stack?
No, not host. I'm saying on the network that we had to deal with.
Okay.
So not a host. We didn't have to do anything to the clients or anything.
Chris?
Hi, Chris Leonard with Verizon. You piqued my interest with the 5G MBMS. I'd be curious if you've had any conversations with any of the vendors like the Qualcomms of the world. From what I understand, and I'm more on the wireline side of Verizon than the wireless, but there's some development needed for firmware for the chipsets to be able to support that. So I'd be curious if you have any experience with that, any feedback if you have.
Yeah. No, we haven't had any conversations with Qualcomm in that area.
Or any vendor, or just in general. It doesn't have to be.
Not yet. Not at this point, no. But no, would be certainly interested to get your thoughts on this as well. So, but no, we haven't explored that area.
Okay, yeah, definitely interested in carrying on that conversation.
Excellent. Okay.
Thank you.
I have a question about reliability. Did you run into issues with packet loss? Presumably this is UDP traffic.
Yep.
Did you have any kind, and I guess at that latency, you can't really do any kind of retransmissions. How do you handle reliability? You lose packets, tough luck, and you hope it's
Essentially, yes. Look, yeah, there's obviously there's always going to be a few packets that are lost. Obviously, we're not absolutely not retransmitting, and ultimately, leveraging, looking at force error correction to a small point, but ultimately, no, yeah, we could, the stability and the reliability, even the handover from APs, just walking from one end of the precinct to the other. So it was quite solid. I think certainly the issues that you come up with is certainly getting there when you've got other wireless routers going through, you've got interference and things like that. As long as you can identify those issues that don't obviously interfere. Yeah.
Did you have to make tweaks to the Wi-Fi, like the access points, to enable more multicast or anything for that, or did they just work out of the box and
I'll get
everything just worked?
Sanjay is first and foremost with this one.
I was going to say, we did what I would say we did do some fine tuning, but nothing over and above what was the levers and the knobs that were already available on the access points and the Wi-Fi infrastructure, right? And back to your early question, Lenny, like, I think the key thing is, right, we have to realize both audio and video are quite resilient to some loss, right? So a lot of the techniques we used were fairly well known in the industry in terms of how to transfer, human perceptible things rather than files and so on, which of course have very different requirements, right? But as Craig said, we did use a forward error correction. And of course, in case you have what we call catastrophic packet loss and things like this, you have the option of going back to a lower bitrate stream and so on, rather than continue insisting on sending 4K, let's say, when something has happened to the underlying channel and you can't support that kind of bit rates.
Any other questions?
Yeah, hi, this is Stig Venas. So did you send the same content basically at multiple bit rates so that the clients could independently kind of change from maybe the high speed video, right, to a lower feed if it had too much loss?
Yeah.
Right, yeah, okay. For IGMP tuning, I guess the tuning was things like query interval or like max response time or things like that?
Yeah.
Right, yeah, that's what I thought. Do you use the IGMP version 3 or version 2? Do you know?
I think it was 2 from memory.
Okay. Yeah, I'm just asking because difference is whether, would be 2 if one responds, the other hosts won't respond, and that might help perhaps. But, okay, yeah, thanks.
Yeah, we can certainly talk more offline on this one.
And the network itself, was it a pure layer 2 network? You're just dealing with IGMP, or did you have layer 3 hops and were you running PIM sparse mode?
Yeah, excellent question. No, this was no layer 3 hops or anything. This was all layer 2.
Okay.
So a single IP network in one address space.
Right. Which reminds, snooping, IGMP snooping. That's a typical, that can be a headache in some places. Did you run into any snooping problems?
Not in that particular implementation that we dealt with a few months ago.
Great. All right. Any other questions? Oh, Omar.
Yeah, I have one question. Can you guys hear me?
Yes.
Very clearly.
Yeah.
Okay. I'm curious about the underlying transport protocol for media. Is it, and like the video that's being transferred, is it adaptive bit rate, similar to like MABR with fragmented object delivery, or is it, MPEG, probably not MPEG TS, which you'll see in a demo here, but there are MPEG capabilities for lossy distribution, MPEG H, I believe, yeah, they call it MPEG media transport, and it supports forward error correction, and it's used within ATSC3. Yeah, there's interest in developing quick extensions, media over quick multicast extensions. We've developed something similar to MABR, but just trying to get a lay of the land of what people are doing and any success you've had with adaptive bit rate or low latency on that front.
I was going to say, thank you, Omar. I think this probably is another topic that merits a longer discussion, but we did not try adaptive bit rates, right? I think we were doing more. You have multiple streams at the same stream at multiple bit rates available, and depending on the current environment for a given client, that may choose to receive one versus the other, right? So more of a static situation rather than try and adapt the bit rate and have all the challenges that come with trying to adapt and so on.
So is it an MPEG stream that you're sending, or like an adapted HTTP video stream?
I'm not sure what you meant by the latter.
So like fragmented video versus a continuous MPEG stream.
Good question. I don't think we want to discuss that here, unfortunately.
Okay. That's my question. Thank you.
Great. All right. Looks like it's it.
Excellent.
Thanks, guys.
Cheers.
Thank you.
All right, Omar, good timing. You're up.
Perfect.
Let me bring up your slides. So you have two presentations, multicast in the browser, as well as the other topic.
Yeah, they're both in one slide
One
deck.
deck?
So, mhm.
Great. All right, you basically have until the top of the hour, so the rest of the meeting is all yours.
Oh wow.
Have fun.
I don't think we'll need all the time, but hopefully we'll have a good discussion. Okay, is that running? Cool. And my controllers. Where is the slide control?
Oh, I'm sorry. I have to. There you go.
Cool. And I also want screen share for a little demo. Cool.
I think you can only do one or the other. You can either present the slide or ask for screen share. So maybe I just give you the whole screen.
All right. Well, when we get to that point, have you switch me over? So, yeah, thank you for having me, number one. And yeah, I'm Omar, founder of Broadcast. We're a content delivery network and really focused on enabling multicast capabilities into third-party ISP networks. So as opposed to campus networks or closed venues, how can we bring multicast out to the WAN? There's a lot of challenges with that, and we've taken interest within the TreeDN architecture, and that solves kind of the all or nothing problem and provides a way for developing native multicast applications, which don't exist, right? So one of the challenges, and want to give credit to Jake Holland for the work he's been doing on this over the past number of years, is how can we make multicasts a first-class web experience, and that's primarily for the demand side usage of it. That in over-the-top world today, you need things like server-side ad injection, interactivity, and it's a wild west, so to speak, of multicast applications today. And up until now, it was kind of a dream to get it in the browser. Want to share a little bit about kind of the exploration that have been doing on getting multicast closer and closer to end users, and a little demo of using new functionality in the browser to tap into the TDN network. So just to recap for folks who are coming across this for the first time about TDN, is very compelling, not just for multicast, but also for unicast. And that, for traditional CDN, you have to have an x86 at the edge of the network. And that's an additional appliance. As you grow your network, you need to have more of these servers. They're, processing packets and replicating them in user space. And most of the time, they're kind of idle. It's only for really large events. You're planning for your peaks, but most of the time it's idle. What's very interesting about the TDN architecture is using the router cards themselves in the ASICs to handle that packet replication. You need to have a router at the edge of your network. So the proposition of handling that replication more efficiently without needing an x86 can drive down the costs of packet replication, but it also has tangential side effects, which are what attracted us to this problem to begin with. Number one is ISP participation. It encourages and makes it easier for them to set up packet replication or media distribution on their own accords, using on their own hardware, without having to qualify for an appliance. Existing hardware that we can put into production is very interesting. And more importantly is that it provides an incremental path towards multicast, that we can start developing multicast native applications. And as demand for them grows within an ISP, that they have a stronger incentive, even without commercializing it, to switch over to multicast. So kind of seeing this as a three-step process of how we're actually deploying multicast in the WAN. One is, first just pushing it within a ISP to the edge, and from there, being able to go out to the consumer edge, and we have a growing ecosystem of modems and so forth, some smart televisions that are capable of running SDKs or servers to handle adaptation of multicast. But now, and long-term vision is to be able to actually get that multicast to the browser. So as of October, the web incubator for the W3C rolled out a new updated version of the Direct Sockets API that allows for UDP and multicast in the browser. So using native JavaScript, you can open up a UDP socket, join a multicast group, and there are some caveats. Number one, it's not just any web page that can open a UDP socket. There are security considerations around that, but the vision is to include it in what they're calling isolated web applications, and these are sandbox within the browser, but have a elevated set of permissions than your typical website you're visiting. You actually have to explicitly install it. So that's one caveat, and to actually get these permissions, right? So right now you actually have to specify within the browser because it's experimental. You need multicast permissions. You want these direct sockets in your IWAs. And that's fine, but because it's experimentary right now, but there still is some reluctance on making this publicly accessible to anyone who wants to ship an app. So right now, the Chrome team has kind of limited the publishers who are capable of listing applications with this set of permissions, mainly targeting kind of enterprises and managed devices right now, like digital signage and so forth. But there is a plan for making this more generally accessible, pending some, security considerations and the discussions that we're having within this group. So one of the critical limitations of it right now is that there is no source-specific multicast support. It's just ASM. So hopefully we can get Chrome to actually add that to the API before it's finalized. But for right now, it's still interesting because of AMT, that we can overcome SSM limitations or multicast availability using these relays. So what we have for this POC is, the TreeDN network, the video sources that are hosted there by, Geont and some universities, and a isolated web app that is compiled Golang, actually. So we can run WebAssembly directly within that sandbox. So we have essentially, our library for AMT decapsulation. It's open source. You can go check it out. But rather than implementing all that again in JavaScript for a proof of concept, compiled, go directly to WebAssembly, and that's what's running there. And that handles essentially the decapsulation. It handles the, relay management, group management, and also exposes a number of output servers. So one of the things that you can do from an IWA is actually run a full-on web server, UDP, TCP, and this allows for, other tabs or applications on your system to receive that decapsulated multicast stream. So for this POC, we're just fetching the direct raw MPEG TS from the AMT relays. So while we have developed technology for HTTP adaptation of HLS, Dash, on-demand or live video, there are limitations to compiling full web servers in WebAssembly that have not been able to solve yet, but just serving MPEG TS directly was not a problem. So I will show you guys a little demo.
Are you ready to do the demo now? You want me to give you screen access? All right, request it again.
Where are we?
There it is.
Oh, the slides are, okay, I think maybe I have to stop the slides and then do the screen share.
And Omar, just a heads up, your volume is very high. It's probably the room. So if you feel that you don't need to speak as loud as
okay,
we can hear you well.
You should just start whispering.
Let me see if I can turn that volume. That's my volume, but not my mic. All right, I'll try not to blast your eardrums. Can you guys see my screen now?
Yeah, it's in inception mode.
Inception mode. Oh, okay. Just this endless repeat. So here we have a collection of web apps. So normally you'd be able to go to a website that has a progressive web app or isolated web app. It comes up, the address bar, like there's an application you can install. You install it, and we got our cross-platform native AMT gateway. So this is just a simple interface to demonstrate the proof of concept, pulling in a number of pre-configured streams from the TreatyEnd menu. This is connecting to via the GW, the George Washington University relay. And when we join, you'll see that it will connect to that relay. And we can see that there's data transfer happening. And there you go. You got some MPEG playing back. What you will notice with this demo is, it might pause. And then, okay, if we start playing back, it should resume. But essentially, because of the nature of MPEG TS and the timing frames, if some of those keyframes are lost, essentially the player will complain, give up unless you add some retry logic. So this is a limitation of using applications that are designed for unicast HTTP or quick without port error correction. Is it's going to stall. But yeah, you can open up any kind of UDP stream, and there are output servers that can ingest it. So this is just the streams that I had set up for the demo, but if we'd switch to MMT instead of MPEG TS, which allows for partial frames, we would not have this issue.
And just for those not familiar with this demo, this is coming from menu.treatyend.net. That's the multicast menu that you guys may remember Lauren has she built, and it is a place where folks on multicast networks can advertise their sources, and anybody can join them. And this is this particular source that you're showing is coming from Géant in France, Belgium. They are basically looping an old training video on PTP continuously. So it's being multicast natively across the Géant network to George Washington University, Karen, actually Capital Area Research Education Network, which connects to Internet 2, and they have an AMT relay that you're essentially connecting to.
Yep. So we're playing back directly off of a router. That's the point here. So this is a proof of concept to show what is coming and what we can do. Back to my slides. Tell you a little bit more about where we're going with this.
Do you want me to bring up your slide again, or do you want to just show it yourself?
Yeah, let's just.
Are you? Okay. We can go either way.
I don't have anything else to demo, so
okay.
We'll just
yeah, there you go.
Thanks. Thank you. Yeah, so just raw MPEG TS that we're playing back there. And the idea is that you can play directly in the browser, different tabs, without needing third-party applications. But yeah, we are not playing back a loss-tolerant stream. So particularly with JS and the overhead there, it's a little bit more lossy, not optimized or anything like that. So, but yeah, the reality is though that everyone who is delivering OTT video is serving either HOS or Dash. MPEG TS is just for, you know, linear television, satellites, terrestrial broadcast. So it doesn't have that interactivity. It's also, yeah, unless you're using MMT, which there isn't any browser support for, you end up with kind of choppy streams. So that's why we have MABR and those kinds of protocols. So what this is tying into, right, is, okay, you have the end application, right? We're trying to make it easier for customers to bring their unmodified web apps and serve them over multicast. And the extension that we're trying to develop here is essentially to integrate ISP edges into a marketplace. And, you know, ISPs are not going to be serving very rarely are serving their, you know, or running their own TV services or OTT services. We're talking about third-party content primarily. So how do you actually bring that into a provider network? And how do you commercialize that? Well, it's certainly not the case that large content providers want to form relationships with you know, thousands of ISPs, especially the long tail of WISPs. You know, there's over 30,000 unencumbered TV broadcasters. So as those are becoming a native IP, right, how do we incorporate that unused capacity into the economy? So we're developing a open marketplace that allows for anyone who has an appliance, a router, or an edge cache to participate using open caching as a common configuration. And we provide the technology to providers who want to participate. You have the challenge of how do you actually convince a customer that they should pay for a provider that they've never worked with or never heard of. They're claiming they have multicast, but who can they actually reach? How do you quantify the value of enabling multicast in a WAN? So that's where you know, the open capacity marketplace is introducing the proof of bandwidth primitive and a draft that I've submitted that is accompanying as well for proving out how many of your users you're able to reach in a network, and essentially allowing the market to understand the capabilities of an ISP or a broadcaster to serve an audience, be it over unicast or multicast. So yeah, the idea is, you know, you're coming in, we have a number of large CDNs who are participating, and we want to offload to local providers where they have better coverage. So how do we actually understand that coverage and capabilities of ISPs or broadcasters? And that's where this draft I'm introducing comes in, called SONAR. And it stands for Statistical Observation Network, Attesting for Receiver Coverage. We love acronyms in this group, so I had to come up with one. So it combines 3 different layers. Number 1 is essentially the content authentication, and credit to I just came across that authentication scheme. I think it was Kyle that you shared that on the mailing list, but essentially you have an authenticated stream coming from a broadcaster, and you want to know how many people they can reach. So we have an authenticated stream, we send it to a statistical representation of the audience. Let's say you have 10 million people you're trying to claim you can cover in New York City with a TV station. So we can take essentially a verifiable random function of all those users that you're claiming to have coverage of, and send essentially a request for them to record what they've received, the data rates that they've received, essentially message authentication codes, and we're able to put that onto a read-only or append-only ledger blockchain within, say, 10 seconds. And everyone reporting, we would be able to verify, their just through 2 data points, essentially using the German tank problem. We can just look at, let's say we're sending 10,000 people, 10,000 packets. We look at the total number of packets received, as well as the index of the very last packet. And using the Poisson distribution, we can get essentially the loss that was encountered, given that we know what the bit rate that it was sent at. So by knowing the loss parameter of every single attestation, we can sniff out people who are trying to cheat the multicast coverage through unicast replication. If we're sending out to a large enough population in a metro over multicast, and they try to replicate it over unicast, you're going to end up with saturation of that network and detectable loss. So yeah, that's kind of it at a very high level. We are taking all of these attestations and recording them in a ZK snark, which is essentially an anonymizing aggregating function that's verifiable. We can perform queries on it without actually exposing any of that sensitive information to see the total number of people who reported, what was the average loss, and we can do that in a privacy preserving way, and essentially record a succinct representation of those challenges and all those receiver attestations very concisely on the blockchain. And we run this verification periodically to be able to cover that entire population. And yeah, essentially verify for a particular network what is the reach of multicast within it. This protocol is an extension of an existing one that was developed at Princeton that was focused more generically on how you would essentially verify the bandwidth of someone on the internet, essentially saturating their connection, verifying that they're able to receive without loss. So multicast extension is very, very similar. And both those constructs together tie into the marketplace. So if you're a unicast only provider, we send you a unicast challenge. If you're multicast enabled and you have 10 megabits per second, you can reach 10 users. The equivalent of your capability in delivering multicast streams is simply the number of users you're able to reach times your bit rate. So essentially, we're able to provide a consistent way for looking at an ISP, knowing how many people you can reach either by unicast or multicast, and be able to, come up with your own pricing. So, that's the inspiration for, incorporating ISPs into a kind of shared permissionless control plane for content providers to leverage as they do regular CDN. So future work for what we're trying to do with this extension is to develop, first of all, just a extension that can be used to verify recipients and coverage of multicast streams. And what we're trying to do is incorporate our multicast adaption HTTP proxy into the browser extension. So right now we've deployed essentially we developed a technology that can convert HTTP to multicasts reliably, either push-based like MABR or MAUD, but also on demand. So essentially the receiver that's interfacing with some HTTP application can send GET requests to upstream of the network, the packager that would go out to the web and respond in real time, such that all the receivers downstream would be able to cache that response and use it when they need it. So the goal is to make that easier for users to deploy. Right now we're deploying this within modems and edge infrastructure of ISPs and so forth. But yeah, the more people we can provide this adaption proxy to, essentially the bigger the market can be and more people we can serve. So yeah, that's something we have today. So we're trying to integrate that, but thinking a little bit longer term, would love to bring up the topic of multicast extensions for media over quick. And essentially, we're going to have a protocol with low latency that's push-based, right? It's very, very similar to the way a multicast stream works, but in the browser. So having work begin on these multicast extensions will provide a strong impetus for the Chrome team to, make this more accessible. There are security considerations within, the draft that calling for this working group here to get involved in. Yeah, so that's kind of it at a high level. And yeah, inviting you all to check it out. I've got a little demo on my GitHub, and looking for folks who are interested in participating in the open capacity marketplace. If you are an ISP or a provider who has multicast enabled, to provide feedback on the Sonar draft and how we can actually quantify their multicast capabilities to third parties and make it available on the marketplace. So yeah, I'll take any questions. And I will add one important thing is, so how do you actually prevent like Sybil attacks? Imagine if you're building a network that is, incentivizing people to go out and verify that they can receive multicast. How do you stop essentially bots from creating large numbers of accounts? Forgot to mention that there is a staking requirement. So essentially for both the receivers and the provers, that they have financial stake. For a receiver, it can be a dollar or something like that. For a broadcaster, it would be a larger stake. But essentially, this is an essential piece to the trustworthiness of the protocol. And if you're able to identify someone who is cheating, that there is ways in which you can penalize them. So it dissuades bad actors.
Omar, you mentioned early on that this was using open caching. Did you mean open casting?
So the open capacity marketplace is using open caching, open casting. Open casting is a extension to open caching that provides a number of different parameters that you can add to a service, like specifying the number of audience or recipients on a stream before you'd switch from unicast to multicast. For instance, on 5G, for multicast, you have to assign a whole bearer to it. So it's something like 8 time slots that get consumed. So unless you're serving to 10 people a particular stream, it doesn't make economic sense to do it over multicast. So open caching is the CDN interconnection, configuration interfaces, providing standard ways for content providers to program CDNs. And the goal of that here is to, within the multicast adaption solution, provide a identical experience in leveraging multicast to leveraging unicast, just DNS, and making it as easy as possible to configure that CDN using open standards.
And thank you. And with this MAHP architecture, does the source need to, is there any coordination required with the source? Do they need to do anything special? Or can you literally make this work without their involvement, and you basically take their unicast, turn it into multicast, and then turn it into transit through your network, and at the end turn it back into unicast with them not even knowing or caring?
It is it does require their involvement for TLS. So, right, how do you actually get the user to that application, to that particular server that's within their modem? Is there's got to be some routing infrastructure to handle that. And it has to be able to terminate TLS. So that kind of permissioned termination does require, go in, set up your DNS, verify with Let's Encrypt. That's largely it. There are additional things that you would need to change if you're concerned about latency. So it does work with on-demand, just get requests. But if you are interested in live video, that we do support, play out of manifest. So you would have to specify, here's my manifest. These are the representations that I want to send. And essentially the sender will be the one to initiate the packaging and distribution for lower latency. So that does require you set URLs in some configurations.
Gotcha. Great. Any other questions for Omar? Okay. Omar, you have 10 more minutes if you want to move on to your next talk.
So this was kind of embedded in it. That's all I've got here.
Okay.
So this draft coverage verification is posted. Would love to get some feedback on it. Yeah, also the code for the demo is on my repo. If you want to check it out.
Great. Thank you. Any further questions for Omar? All right. Any other items at all for the rest of this meeting? Okay. All right. Well, thanks everybody for coming. We'll see you in 125. Thanks, Omar.
Thank you.